All right, ever wonder how our solar system actually works? Or, what's literally miles beneath your feet? Well, in this explainer, we are going on a super fast tour, from the sun all the way to Earth's core. We're going to arm you with all the essential stuff you absolutely need for those big competitive exams. So you ready? Let's dive right in.
So, let's be honest. If I gave you a pop quiz on our planet right now, how would you do? Think you could ace it? Well, we're about to find out. We're going to blitz through all the must-know facts of world geography. We're talking from the edge of the solar system right down to the Earth's fiery core. This is your chance to see what you really know. Let's go.
Okay, first up, let's tackle a classic, and I mean a real classic exam question that, believe it or not, trips up way more people than you'd think. It's the order of the planets. If you can get this right, you are already ahead of the game. So let's lock this one in, shall we?
So what's the secret? How do you never, ever forget the order of the planets again? It's this simple phrase. My very educated mother just served us noodles. Come on, you know this one. That's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Say it with me, wherever you are. My very educated mother just served us noodles. Let's do it one more time just to really drill it in. Perfect. Now you're never going to forget it.
Now, it's not just about the order. You gotta understand that our solar system is kind of split into two very different neighborhoods. You've got the inner planets, Mercury, Venus, Earth, Mars. These are the rocky, dense, terrestrial guys. Then you've got the outer planets, Jupiter, Saturn, Uranus, Neptune. These are the massive, gassy, Jovian giants. Knowing this difference between the rocky inner planets and the outer gas giants, that's a huge concept for any geography exam. All right. See if I can catch you out with this one. It's a classic trick question. What's the hottest planet in our solar system? Go on, have a guess. If you said Mercury, hey, that's a good guess. It's the closest to the sun, right? But it's wrong. The answer is actually Venus. Why? Well, it's all about its crazy thick atmosphere. It's like a super heavy blanket that traps all the heat, creating this runaway greenhouse effect. That's what makes it the hottest planet around.
Speaking of Mercury, since it's so close to the sun, it just zips around in its orbit. 1 year on Mercury, just 88 Earth days. That's it. Imagine that. You'll be celebrating a birthday roughly every 3 months. Wild, right?
Okay, now let's jump all the way to the other end of the line, out to Neptune. It is so far away from the sun that it takes a whopping 164 Earth years to go around just once. I mean, think about that. If you were born on Neptune, you wouldn't even live to see your first birthday. It's just a perfect example of how much that distance from the sun really changes everything.
So we've seen how the other planets do their thing. Now let's bring it all back home. We're zooming in on good old Earth to really get a handle on the two key movements that basically define our entire lives. The things that give us day and night, our years, and of course, the seasons.
Rotation versus revolution. Okay, these two get mixed up all the time, so let's make this super clear. Think of the Earth like a spinning top. The way it spins around on its own axis, that's rotation. It takes about 24 hours, and that's what gives us day and night. Simple. Now, the path that spinning top takes as it travels around the sun, that's revolution. That takes about 365 days, and that's what creates our seasons. See? Rotation is the spin, revolution is the trip.
So as the Earth makes that big journey around the sun, there are 4 key moments, 4 special dates that mark the seasons. You've got the equinoxes, one in March and one in September. Equinox literally means equal night, and that's exactly what happens. Day and night are pretty much the same length. Then you have the solstices. These are the extremes. The summer solstice in June is the longest day of the year for the Northern Hemisphere, and the winter solstice in December is the shortest. These aren't just science facts. People have been tracking these days for thousands of years.
All right, we've been looking up at the sky, so now let's look down, way down. We are about to take a journey to the center of the Earth. So forget about space for a second. We're going to drill right through the ground beneath our feet, peeling back the layers of our world one by one, all the way down to the super hot core. So how do you even begin to picture what the inside of the Earth looks like? Easy. Just think of it like a giant cake. Seriously, it's got all these different layers. If you could just slice a piece out, you'd see everything, from the thin, brittle frosting on top, right down to the dense, heavy center. Okay, so let's look at the layers of our Earth cake. Right at the top, the part we live on, is the thin crust. You can remember its composition with the name Cl. That's for silicon and aluminum.
Below that, you've got the really thick middle layer, the mantle. We call that one SEMA for silicon and magnesium. And right in the middle, the super hot metallic center, is the core. Its nickname is knife, which stands for nickel and iron. See? Cl, SEMA, knife. Crust, mantle, core. Got it?
All right, you ready to level up? This is for those of you who really want to ace that exam. See, the boundaries between those layers we just talked about, they have their own special names, and you better believe they show up on tests. To remember them all, in order, from top to bottom, all you need is this one funny little phrase. Con mare gulel. Yeah, I know it sounds weird. Let's break down what it actually means. Okay, here's the code. Con mare gulel breaks down into 5 key boundaries, or what scientists call discontinuities. Con is for the Conrad discontinuity. Ma is for the Maharovicic, or just Moho, discontinuity. Re is for Ripetti, Gu for Gutenberg, and Li for Lehman. You know, the Moho is probably the most famous one. It's the line between the crust and the mantle. Honestly, knowing these names, this is the kind of detail that can push your score from good to absolutely great.
Okay, let's head back up to the surface. Because all that crazy heat and pressure down in the Earth's core doesn't just stay put. Nope. It's like a giant engine that drives everything up here. It's what powers volcanoes and creates the very rocks that make up our world. When it comes to rocks, there are really 3 main families, and each one has a totally different origin story. First, you have igneous rocks. Think ignite. These are born from fire, formed when hot magma cools down. Granite is a perfect example. And hey, no fossils here. Then you have sedimentary rocks, like sandstone. These are made from layers and layers of sediment, sand, shells, you name it, all pressed together over millions of years. This is where you find fossils. And finally, metamorphic rocks. These are changed rocks. They started as igneous or sedimentary, but then intense heat and pressure transformed them into something new, like marble. Okay, we've gone as deep as we can go, all the way to the core. So now there's only one direction left to travel, up. We're going to soar up through the different layers of our atmosphere, that invisible protective blanket that literally makes all life on Earth possible. Here's another great exam question for you. We all know what's in the air we breathe, right? Well, what's the 3rd most common gas in our atmosphere? Everybody knows nitrogen is number 1, oxygen is number 2, and almost everyone guesses carbon dioxide for number 3. But nope, it's actually argon. It's one of those brilliant little facts that can really make you stand out on a test. Just like the Earth itself, our atmosphere has layers. Think of it as another cake. The bottom layer, the one we live in, is the troposphere. That's where all our weather happens. Easy. Go up a level, you hit the stratosphere. The big deal here, the ozone layer, which is like our planet's sunscreen. It's also where jets fly to avoid turbulence. Above that is the mesosphere, the middle layer. And then you get to the ionosphere, which is super cool. It's what lets us bounce radio waves around the planet. Each layer has its own job to do. Wow! So we started our tour way out in the vastness of space and ended it by exploring the invisible layers of air right above our heads. And I think if there's one big takeaway, it's how all of these systems are so perfectly interconnected, so delicately balanced. So I'll just leave you with this to think about. Of all these systems we've looked at, the planets, the core, the rocks, the atmosphere, which one do you think is the most fragile?